Hello. Uh, I'm gonna try to solve the flare-on checksum challenge. I'm probably not gonna be able to do it because my goal, I'm learning reverse engineering and assembly x86. So my goal is more to use the challenge as a way to learn. So my focus is not gonna be so much on trying to solve the challenge, but trying to think about uh, which ways to approach these kinds of challenges. My intention is not to solve the challenges as well. It's more about to learn, like the tools that people use and how to think about these kinds of things. So the main thing, like up until I think 2 days ago, I was using only x64 DBG, but once I opened so the way that the challenge works, as far as I know right now, is they just give you an executable file, and then you have to figure out the flag by exploring the executable. So the way you can do this is by using these debuggers. So obviously I don't know very much how it works. I'm just learning everything. But from what I know, x64 DBG is for runtime analysis, which means that there's two differences. Like one part is the static part, which is just the code on the file, and then the other part is what happens when you run the code. And the main difference between the two is going to be the inputs. So when you're just reading the text, there's no way for you to see what is happening with the fluctuation of the values on the variables. But when you are running the code, you can see what is going on actually when you're executing. So the x64 DBG is more for when you're running the code, and this IDA is for static analysis, which is just going over the source code of the executable. And as far as I understand, the way that they do this is by taking the executable. The executable is just going to be a bunch of binaries, and then based on the instruction set architecture, you are able to decode the instructions on assembly, because the instruction set architecture is just going to be some logic circuits on the hardware that are predetermined to do some operations. And that's basically how most of the computers work nowadays, is the von Neumann architecture. So you have the fetch part of the cycle, which takes the instruction, just the predetermined binaries. Then you have the decode, which is decoding based on the instruction set architecture what the binaries are supposed to do. Then you execute, and then depending on what the instruction is going to be either a branch, which changes the value of the current instruction being executed, or is going to be something to do with memory. So based on what I've seen from the IDA here, it seems that it's a lot easier to understand what is going on, the challenge going over with the IDA. Because the problem with the x64 DBG is that it only allows you to go. Obviously, I don't have too much experience, so there might be different ways to use it. But from what I've been using, it only allows you to check one instruction at a time. It's very confusing to keep track of the control flow. So you can press G to transform everything into a graph. So depending on the options, on the preferences you have here, is going to stop the code that's at different points. So before I was studying, so you can use this to study the operational system as well, which I think I might do. Because before the executable loads, Windows is gonna load a bunch of dynamic linked libraries, and it's gonna initialize the process, because everything running on the hardware is gonna be a process that is managed by the operational system. So each process is gonna have a predefined way that they deal with the memory and the instructions and everything that is going to be executed. And yeah, so here you can control what stuff is gonna, the x64 DBG is gonna automatically stop at, so the breakpoints. And based on the ones that I have right now, I think it is only is stopping in the beginning of the execution of the executable you open with the debugger. Then you can double click to put breakpoints as well. Maybe this is a breakpoint that I put before because I have the right thing here. So if I double click here, it goes away. So I think this is a breakpoint that I put before. And you can click twice to go into the address of one of the calls or jump instructions. Calls is a call to a function on assembly, and jump is just jump, which is going to jump to the address. And then to go back to the instruction you are currently at, you can do the asterisk, which is just shift and then 8. And then it goes back to the place you're executing. I'm going to show the... So I wrote down just a few. I found spreadsheets on the just quick search. And then I just wrote down the ones that I think are more useful, at least for now. So one of the things that I was trying to reproduce is the pattern in Vim that I'm using a lot. Just when you press MA when you're using Vim, it's just going to memorize the spot that you were at. And then you could press the... It's like one of the strings operators, like the single, I don't know how to say it in English, but the single string thing. And A is going to go back to the place you were before. So I was trying to do the same thing here because a lot of the times what you want to do is go over, like you want to see where a jump instruction goes to, and then you want to go back to the place you were before. So I do this a lot. And the way that you do, as far as I know right now, like I couldn't find a better way. I think you have to bookmark the place, which is just Control D. So when you press Control D on the current execution, it's going to bookmark, like here. And then you can press Control Alt B to go to the bookmark page, and then you can find the bookmark and then press Enter. And that goes back to the place you were before. And then to go to the jump is just double click. I think minus looks like it goes to the previous instruction as well. I think Control D just removes as well the thing. So yeah, I think I'm just gonna start. I'm gonna step over this. Like I said before, like the reason why I'm doing this is not to solve the challenge, it's just to study with a practical example of study assembly more, and yeah, try to understand or think about. Because for the stuff that I'm doing there, it's probably gonna help a lot. And the main reason why I decided to do this is because of the threads. So threads is very confusing to me, because which goes into the whole nuance about the hardware architecture and operational system, stuff like that. The reason why threads is confusing is because the nuances of the thread execution is gonna involve the way that the operational system is gonna handle different processes. So I was thinking about this the other day. So I have something that's called cache coherence, which is just the way that the operational system synchronizes different processes with the shared memory that they have. And there's different strategies to deal with this. But cache coherence is just basically the same problem that threads have when it comes to races. So whenever I have two different threads executing, so threads is just different lanes of execution inside of a process. And execution is just an instruction. So computation is just basically a line of decisions you make. That's all that it boils down to. And everything else is an abstraction from that. So in modern CPUs, you're going to have different lines of execution, which are different threads. And I think that the CPU is a core. The thing that manages the cycle of execution is going to be called a core, which is basically managing all the threads. I'm not 100% sure about the nuances of this, but yeah. So whenever you have two different threads executing a program, you're going to have nuances on the order of the execution, because what's always happening is that people are trying to optimize how much work you do per time. And there's going to be trade-offs between space and time, because that's what computation is. So usually the more space you use, the faster it's going to be. But then you're using more space, and the other way around also. Uh, so basically, they are inversely correlated. So whenever you have two different places of execution, it's going to be challenging because of the order of the instructions, that they can be reordered both from the compiler and from the hardware architecture in order to optimize the latency of the cycles. So each clock cycle, you want to do the most amount of instructions as possible, and different instructions take different time as well. So this is one level of challenge to understand what's going on, and the other level is the memory, because most of the situations, what is gonna, probably all the situations, what keeps the level of abstraction connected is the memory layer from the computer. So like that's essentially the main difference between a process and a thread, because essentially they are the same pattern. So like the main difference between a process using multiple threads and the CPU using multiple processes is going to be the level of the data of the memory synchronization. So, and this goes back to scope. So this is the reason why I think that threads are kind of challenging to understand, because they depend on the place that the thread was initialized, the way that the process is going to be handled, and how that's going to impact the memory across the execution of the program. So I was trying to I had this problem on Godot, and I was trying to understand. But now I think that the problem is not related to the threads. It's probably something else. I'm not 100% sure. And also understand there. So basically on C++, the life cycles usually depends on the way you're going to do the functions. But you as the programmer is responsible for managing the threads, because it's going to depend on the context of the execution of the program. So the context of the program is going to determine how you're incentivized to create and destroy threads, and how to prevent data races, which happens with locks. So locks, and from what I've seen, there is some places that they have locks on the operational system, on the assembly, but it might come from the higher level, because this, as far as I understand as well, is a Godot code, not Godot, as a Go code. So they probably have mutexes to prevent data races, which is one of the parts that I was confused about. And I found the article that I was thinking as well, which I saved on the bookmarks now. It's not article, it's a Stack Overflow response that I think was very good. I think it was C++. But basically, it all comes down to the memory model. The memory model is the thing that is confusing, and it's still confusing to me, because that's where the synchronization is going to matter. So when you use a mutex, which is something to prevent data races on C++, it's just basically semaphores. So each thread's like a cars going on traffic, and then the locks are going to be the semaphores. And in order to prevent the crashes, you need to synchronize these things. And the movement of them is the memory fluctuating across the execution of the program on space and time. So this is the reason why I found this answer here very interesting. So he basically mentions that a multiprocessor, not a multiprocessor, I guess multiprocessor as well, but a parallel paradigm where you have multiple threads executing at the same time is like spatial relativity. So although each thread has its own view of time, they are synchronized through space. I think that's what's happening. So like you can have a thread that executes a bunch of stuff faster than the other ones, but because they operate with the same memory, they are able to synchronize themselves. Yeah, so that's the reason why the plane is relative to the observers, which are the threads. And I think that's what he's talking about here. So basically, that's kind of the things that I'm trying to clarify more. It's like how the memory is gonna work, and yeah. But from what I've seen here, So I have no idea how to solve this or what I'm supposed to do. But when you open the executable on IDA, it opens this stuff here on x64 dbg. You can press G and then it goes to a graph on the current place that is executing as well, and then you can press G and go back to the thing. So this helps, but it's still very confusing to think about. This is one of the main things that I'm not really sure. Oh, another thing that I want to say here is, because it's probably going to help someone, is this DS here. So the way that you can find addresses, so the way that it works is that here on the right bottom, you're going to have this stack. The current instruction is a register, is determined by a register, which is the I think RIP. Yeah, RIP is so it's basically a value of an address. So it's like a pointer on higher level languages. So these registers hold is a special register that's going to hold the pointer for the stack. And the stack is shown here. On the left bottom, you're going to have the memory on the heap, which I think they call the dump one. And on the top right here, you're going to have the registers. And if you want to find an address on the dump here, you just select one of the address and you press Control G, and then you can put whatever pattern you want here. But this was kind of confusing to me when it comes to these addresses here. So you can right click here and you can put following dump, and then you can either select the address, which is gonna get, I think it follows the address of the instruction. But in this case, I wanted the address instead of here because I wanted to understand what is going on the instruction itself with the data that they are getting from here. So when you have square brackets, it's like dereferencing a pointer on higher level languages. So you pass the address inside of the brackets, and then you're going to get the value that is located at that address. And that's going to be the thing that is used on the instruction. So you can go here on the constant to find that place in memory. And then basically the value is going to be here on the right of the address. But the thing that is kind of confusing is the DS here, because DS stands for data segments. And each process is going to be separated into the stack, heap, the data, the text, and I think one more that I'm forgetting. But it's basically the process is an abstraction, and the abstraction is just the pattern that they select to determine where they're going to put the instructions and the memory for each program that is going to execute on the hardware. And because the process is this abstraction, they used to have these different segments on the process. One of them would be the data segment. So initially, I thought that the address that they put here would be the offset from the data segment. So it wouldn't be the one that I'm looking at here. It would be the one that the beginning of the data segment offset by this value. But now I understand that that's not what's happening. So at least I think that that's not what's happening based on what I've seen on the code. What seems to be happening is that they are putting this just for illustration purposes to make it easier for you to understand. But the address that they put here is the actual address on the memory dump. So if you just click there, it's going to go to the actual address of the instruction, and then this is going to dereference this address and get the value here. So this instruction, for example, is comparing 0 with the value that is inside of this address here. And this stuff about segments, as far as I understand, it doesn't exist anymore. It was something that 16-bit operational systems did, or 16-bit hardware. And nowadays they use a flat memory model, which is just a fancy way to say that they are using virtual pages directly to organize different processes on the hardware. So before, what they had was global descriptor table and local descriptor tables which is just basically two different arrays in memory that they would use to, based on the way you would flip the bits on those addresses, you would get through to the physical address. So this manipulation would is called far pointer. And so you would basically change the bits on the registers that I think is G register or something like that. And based on that, you would be able to, like you would use those bits on those bits would be used on either the global descriptor table or the local descriptor table. And then from those tables, you would go to the physical address, or you would use virtual pages and then go to the physical address. But nowadays, I think it's directly to the virtual pages, and then from the virtual pages to the physical address. So it doesn't matter anymore, this DS here. It's just more straight up the addresses, and you can look at them here. Yeah, so I'm just gonna just step into press F7 to step over F8 and to run you press F9. So what I was thinking about doing is to, so RBX, actually I keep confusing, but I think RBP is the base pointer of the stack and RSP is the top of the stack. So, and this is just arbitrary abstract concepts that people create because the processor doesn't, like the CPU doesn't understand stacks. It's up to you on assembly to build the stack. So I have the prolog and eplog, just constructs of instructions that you usually do when you want to execute a function. So the base of the stack is going to be a special register, which is going to be RBP. On the top of the stack is going to be RSP, and the stack grows towards lower addresses. So usually when you're subtracting this value from RSP, it's just moving the top of the stack. But I don't understand very well, like, because a lot of the times it's very confusing because it's just, this is another thing that is kind of confusing as well, because here is specifying in hex. So as far as I understand, 20 in hex would be 32 bytes, because of the, so like you just elevate 16 by the exponents, which is the square that they are at. So the first one would be 16 elevated by 0, which is going to be 1, times 0, which would be 0. The second one is 16 elevated by 1, which is 16, times 2, 32. So that would be 32 bytes. The other way to think about it is that each hex number is 4 bits. So you would just replace the number with the bits, and then you can change from the binary to decimal later, which is both of the things kind of annoying to do. But the thing that I'm not 100% sure is the alignment here. I think, but I'm not pretty sure, that each row here is 32 bytes, 32 bits, yeah, which is 8 bytes, no, 4 bytes. I'm not really sure though. So this is one of the things that is kind of annoying, because like when I look here, you can kind of guess that's going to be, and I've been using ChatGPT, but obviously you can't really trust ChatGPT output, but it's just a nice way to like quickly see and test things. So I think I asked this to ChatGPT, but I couldn't, I just obviously not gonna trust, so I'm not gonna trust 100%. As I can count this stuff here. So there, assume this is something that happens all the time as well, because it's just how it builds this stack. So usually what happens is you push RBP, which is the base pointer, and pushing just means that it's gonna put the register on the stack, and it's gonna increase the instruction pointer, which is the register instruction pointer, by 4, because each instruction is 4 bytes. So I'm just gonna check, try to check here how many, because I think each square there is a bit. So it looks like it's 16 bits. Yeah. So 1 byte, is this correct? One byte is 8 bits. Yeah. So it's 2 bytes per row. So 2 bytes on each row. So here would be 32. So it would be 2 rows. So 20 is 2 rows. I guess that makes it easier to think about it. Because whenever you see a multiple of the decimal, it's just going to be equivalent to the rows you are putting. Yeah, so it's probably like that that works, I think. So subtracting 20 from RSP should move the top of the stack by 20 up because the addresses grow down. This is something I don't understand as well. There must be a reason for them to do it like this, but it's just super confusing that the addresses grow down. It's not intuitive at all. But here I think it's different. It's not really initializing a function because it's pushing another stack to the pushing another register to the stack. This is one of the things that I'm not really sure how to go about it because it's basically practically impossible to keep track of all the numbers. So I think that's the part that I'm struggling with now. It's gonna push from the counter register the value that it has here to the RBX. And then it's gonna call this function. So I think that the thing that I was thinking about doing is to go over the jump instructions. I'm gonna press F9 and I'm gonna get to the points. Yeah, so this is the first thing that I was gonna ask here. So I was gonna ask ChatGPT, how can I So the first thing that I was thinking about, so basically the way that it works there is it opens a command line and then asks for a sum, and then if you put the sum correctly, it just asks for another one. If you put the sum incorrectly, then it crashes, and if you put correctly a bunch of times, it's just gonna stop giving you the sum, and then you just ask for a checksum. So what I imagine is happening is that obviously based on the responses, you're gonna have some control flow on the executable that is gonna determine where to, it's gonna determine how to get the flag. In order to get the flag, you need to figure out what is the control flow that is gonna allow you to get to the, it seems that it's a picture. But this is the reason why I said that using IDA is a lot easier to figure out. Because just look into this control flow graph here, and then I just followed to the last part. And it seems like here, based on the comments, not about the checksum, is gonna do these checks. Like, so this is what I'm thinking. Like based on the input there, how to figure out what is the control flow that is gonna get me. How can I change the stuff? But like this is the thing that I said. Like my main goal is not to really solve this stuff because I think that's like I think if I want if I went over each control flow and I step over the code and then I just follow like the path there, I think you can change by pressing space. I'm not 100% sure. Yeah, so if you press the space on the current instruction, it allows you to change what instruction is going to execute, I think. So one thing that I can do is find the point there that they have on ADA or IDA, however you say this, and then just follow the execution of the. Each time I find the control flow, I just figure out what beats are have to be sent to do certain jumps, and then I just follow the path here until I get to the block of code that is gonna have the flag, which I think is the last one. And it looks like they put on a picture, which I assume that they are gonna save after you put some inputs. So I think that yeah, it seems that it's gonna be on a cache path from the operational system. I think this OS use this is something that I have to see as well, like how to figure out or how to. Also, if you double click, it goes to the function on IDA. But I was thinking about how can I get the name here? Like how can I find the name on here? Pressing Control F. Hmm. I guess I'm gonna ask this. Because it might be something that IDA puts there after going over the executable. So maybe there isn't the name. Well, I think what's probably happening is using a library on Go that is going to use the operational system. So it's going to find the cache path from the operational system. It's going to save the file, the picture there. I think that's what's going on. And then it's going to create the picture and write the picture with the flag based on the inputs you put there. So I think that the path to solve is this, but I don't care that much about it actually. So these also are true the questions that I have so far. So something that I observed is that they use XOR operations frequently based on addresses and values and addresses. So trying to understand what is the meaning, if there is a meaning behind the XOR. I know that on the ALU for adding things, all you have to do is use an XOR and a carry bit. So XOR is probably just add. But if you don't use the carry, then it doesn't work, I think. So the XOR alone, I'm not really sure why it's usually done. And the other thing that's kind of annoying is that a lot of the times, based on the arguments that they pass to a function, the arguments are going to be done with an offset from their RBP or RSP. So you push to the stack and you push based on the offsets of the value on the stack. But it's kind of annoying to just keep track of the values. So I'm just trying to think about what is the best way to deal with this. A local app data looks like they're gonna use this as well. I wanna go back to the main thing there. This like it feels kind of like cheating using the IDA. In the beginning, I wanted to focus only on one tool, so I don't get overwhelmed by all the shortcuts and all this stuff. So I was planning on staying only with x64 DBJ. So that's the reason why I wasn't sure. I didn't want to use IDA. But it looks like it's a lot easier to just use this, but it feels kind of like cheating. Trying to find main again. So how can I go back to this? And that's treasure pit there. x64, blah blah, set breakpoints. I'm not gonna spend time on this now because I'm probably gonna look into this later. It's like to become better with the shortcuts. It's kind of hard to find. I found many videos about like people explaining like how to solve challenges and stuff like that, but I couldn't find many videos explaining like the fundamentals, like these kinds of things. For example, like finding a function by name or how to label everything and these kinds of things. So to label, I know you can. There's an option here. You can put here label, but like that's not what I'm talking about. It's more like how to search for things and how to. But I guess it's just that I haven't watched a lot of videos yet. So probably after watching a lot of videos, you get a sense for the patterns. But I wish there was a video explaining like the basic stuff, only the basic stuff, and not how to solve the challenges. I'm gonna press 7 here. Okay, so let's try backspace. Ask. So when I press ask, it goes back to the place I was before. So yeah, it looks like it's gonna be on this file here. And the question is, so I'm gonna try to not use this stuff. I'm gonna go over like one by one here. So pushing RBX, subtracting. I was gonna call this. And now NTDLL is, as far as I know now, is a API from Windows. So whenever you see the symbols, it's gonna be a function from Windows. So it's moving the base pointer to this uh, offset of the register. So SS is stack segments, but like I said before, it doesn't matter. All that matters is this thing here. So you take whatever you have, whatever value you have inside of the RSP, which is shown here. Then you increase by 8, and that's where it's gonna put the RBX. So just moving the base of the stack. So stack works like as a linked list where you have these two pointers, and the base is moved. I think after each function, new function call, the base is moved to that function, the address of the function, and then you move the top of the stack to the base after you move the base. Then you move the base more to open space for the local arguments or for the function arguments. Then you push again for the local variables, and you execute. And then once you return, it just remembers. There is like in most hacks are gonna be based on this as well. Just the manipulation of the addresses on the stack and the return addresses and stuff like this. So I think it's gonna be half, since based on what I said there before, I think each row is gonna be 16 bits. So the offset from the RSP plus 8 is gonna be the first half of the first row. Or the previous row, because when you increase, because the stack grows towards negative lower addresses, when you increase, you're going back. So it's putting the RBX 8 bits back from the top. But RBX is not the base, it's RBP that is the base. So not sure what's going on with but maybe it's not the first row there. Like I'm not 100% sure. I have to clarify more how these offsets work. LA stands for load effective address, so it's gonna get the address that is on the RSP plus 8. It's probably this one. The offsets I'm not 100% sure, like I said before. So, but I think it's gonna get the address from this place here. So let's see, and load on RSI. Yeah, so it is. Yeah, it is the same here. So you can see 3629 FF 740, 3629 FF 740. So it's just loading the address on the stack that is uh, one row below the current top. The other thing that is kind of confusing is that when it goes from the memory dump to the register, you have to invert the values. So it's not the same order, and I think that's just because of the Indianness of the system. Those details, like I'm not that much concerned right now, but obviously it is important to understand this, but I'm more concerned with the patterns first, then I'll clarify the details later. Checksum is going to be a function from the executable, the label. So I'm just gonna go like press F9, I think, to get to the point. Yeah, it's basically this. So it already opened the command line. I guess like this is the main thing that I'm trying to figure out now. So after you put the input, what function is gonna have to run a function for the kernel, and I think it runs from the operational system. So it calls the operational system as an API to interface with the kernel because that's what's gonna create the output here. So there needs usually, from what I've seen, people say that he's gonna put the stuff on the buffer, but I like, what do you mean by that? Like, is the buffer gonna be on a register or like? So I'm trying to clarify what sequence of things happen directly after you put the inputs, because obviously once I understand where they put the inputs, then I'm gonna be able to figure out the control flow after that. I'm just gonna press F9 a bunch of times. I'm also probably gonna use this to study because that's another thing I was thinking about, like trying to understand more the standard library on C++, and I think that's probably the best way to do it. Because a lot of the times here, like I saw before there, saw culture memset, you can look into the actual implementation of the functions on assembly by stepping into the functions here. So that's the best way to learn, I think, probably, what exactly these functions are doing on the process. I'm just pressing F9 a bunch of times. And kind of one of the things that I regret about this is because I put a bunch of breakpoints already. In the beginning, I also put other breakpoints when it's loading the DLLs and stuff like that to study the other operational system stuff. And it's kind of hard to figure out now what part of the cycle I'm at. But I think that this part here is related to the loop that happens after it has the input there, after it shows the equation. Because I think that's why I put a bunch of breakpoints here on the jumps. Yeah, so here it looks like it is stuck now. Yeah, so now it's asking for the thing. So I think I'm gonna put the breakpoint here. So let me use a calculator. I was gonna also, something that is useful is that you can put programmer here, and it allows you to see stuff. So basically 20 hex is gonna be 32 decimal, yeah. because each square is like the power of the thing that you're gonna raise, and it's the same in bits. The only difference between bits and hexadecimal is the base. So hexadecimal is 16, bits is true, but you elevate that number and then you multiply by whatever value you have there on the square. Yeah, so this is something that I've seen last time as well. If you wait for too long, then it hits the breakpoint here. So assume there's something happening that because I don't have the breakpoints, it's not showing after the last point there. I'm gonna do the math and so I'm gonna press F9 here a bunch of times to get to the points again. Also, it is going here, so maybe I should try to, or maybe I should put the breakpoints on all the places here. So now let me answer this thing 721. Yeah, so now let's see if I can figure out. The problem is I'm not really sure if this is what's happening right after the, but it probably is because here, like this seems to be the function that is like has the loop that is stalling, waiting for an answer, I think. But the thing is, it's not calling. So it's gonna move the EAX. I think I've seen this a couple of times. So moves EAX through EDI. EDI is usually the register that's gonna have the destination, and I think it's usually used for strings. So you have ESI and EDI. ESI is source, EDI is destination, and they are both represented with R here, because this is another part that is very confusing about assembly, but usually the registers on 64 bits are going to be the R registers because they have 64, and the E is going to be the 32 bits, the first 32 bits of the 64-bit register. And then they have other variations as well that is like smaller bits from the main one. And you can basically assume that based on the letter in the middle. So RAX is the 64 bits, EAX is going to be the 32 first from the RAX. And I think that is the same with RDI here, which is going to be the first 32 from RDI, I think. So you have 0 on the EAX, going to move to the RDI, which is going to be 0 now. Now it's moving 0 to the stack. 48 on the stack, which is going to be 3 rows from the thing here. So 3 rows before, so I think it's going to be here. This part I'm not 100% sure. Because so maybe because it's moving EAX, it doesn't override the other values on the other parts. But I'm not really sure because EAX should be 32 bits. So maybe it's the wrong value that I'm seeing there. Or it was this one. So 1, 2, 3. Yeah, it should be this row here. Double word should be 16. So maybe that's why. I think a word is 8 bits. Double word is 16. I'm gonna ask that to ChatGPT. So I'm gonna ask. Usually, what I've been doing is just asking ChatGPT based on each instruction, and then if I think that there's something wrong, I just search somewhere else. 32 bits. So the word is 32. 4 bytes. So if each row there is 16, and it should override 2 rows from the thirds. Lower 32, yeah. 16 bytes per row. Yeah, so I was correct. So it's 3 rows down from the top, and it's gonna override 2 rows with a EAX value, I think. Or maybe not. Oh yeah, it's because I'm confusing the hacks with the bits. So it's 48 hacks, so it's not gonna be 16. So 48 is gonna be 64, 72. 72 divided by 16, so that's 4. This is so like, and this is one of the parts that I'm struggling to find videos about. So I'm not really sure how people usually do this, because it seems kind of impractical and slow to do everything. Like either do everything with a calculator or to do it in your head. But I guess it's just a habit, so I get used to roughly gauging how many it's gonna be. So it looks like it's gonna be moving the value, so 32 bits, into the around 4.5 rows below the current stack pointer, which was here, I think. Instruction moves 4 bytes. Yeah, but it's very, very weird because it didn't override anything. This one is zeros, but so it's 32 bits there, so it should override 2 rows from that address. So whatever, I'm just gonna continue. This one is another very confusing one. So the task does a bitwise end, and I think usually when you do it from, so like after you do the task, it's not gonna change the values on the registers. It's just gonna set a bunch of flags. Then based on the flags, it's gonna do a jump. So usually when you, I think always when you task with a register with itself, you're just checking to see if the value there is equal to 0. And if it is, it's gonna set the flag, I think. So it sets the 0 flag to 1 if the task is 0. So the only time that's gonna be 0 is when the true values are 0, I think. But this part's very confusing to me. And I think it sets this JS here is jump chart. So this is jumps if the sign flag is set, but the sign flag is only set when you have a negative value. So I think basically what is happening here is just checking if EAX is a negative value. but I'm not really sure if it's equal to 0 as well. So it's basically on a high level language is gonna be like this. If uh, if ax 0, then blah blah blah. But it could be equal as well. And these flags are kind of confusing because of the names of the jumps. And so this one doesn't take, so it does the same thing on ESI. Just gonna be 0 here. So this one is gonna jump because the ESI is 0, so it jumps to this thing here. And so, like, this is the thing. I think it should have a value already. Like, the value should be somewhere. Let's Control D this and go here. So I think it's on the syscall here. So the syscall, as far as I understand, like the name sounds, going to be a system call. Which I think that this is the thing that opens the command line there, probably. I have here as well. There's a bunch of places where it has syscall here. I think what happens is inside of this function, it opens up the command line and then it waits for the command line here. But the problem is like how does other figure out where it's gonna put the data. So I think it might be on one of these registers. No, don't think that's probably not. Just gonna press. I think it's Control Shift B, and then I press Enter, and it goes back to the. But this is probably the other one that I had. Oh, maybe it's this. Yeah. So Control D. So this is gonna jump to this thing here. So here obviously it's gonna tell us again, so it's not gonna jump because it's 1. Yeah. So EDI is gonna be 0 as well. So it doesn't jump. So it's moving EDI to EBX. So it's gonna 0 this register here. Then it moves this one to the RAX. This is another annoying thing. So B, I think is 11. So being hexadecimal is 11 in decimal. And the way, so this, I kind of stopped. I have to go back to doing Anki at least a little bit every day. But I found that Anki is not very good for certain things because you need, it's only good if you build the cards, which takes a lot more energy to do it. Like on the PowerShell and the bash commands, it is like because of how low effort it is to do it, I still think it's kind of worth it, but it's not very good because the cards are not grounded into the like contexts that are practical. So even though I memorize a bunch of stuff, it's kind of hard to think like when you're faced with the problem, it's still hard to think about the solutions because it's not like it's not grounded into the patterns you learn, if that makes sense. So the problem is that the design of the cards is the challenge. So the ones that they have here that I got for free that people built, I didn't find very good to. There's a bunch of commands here that I memorized, but like it's kind of hard to find like it's kind of hard to think about the command in the context of something you want to do. But the hexadecimals one is very good to memorize this stuff. So I think E is gonna be 3 bits here. The F is gonna be all of them. B is 2 bits here and 1 bit in the beginning, I think. No, that's D. Yeah, B is the other way. So D is 2 bits here and 1 here. And B is uh, 2 1s here and 1 here. 6 is shown in the middle. Is 1 part. This is 7, I think. So, but it's still kind of hard to translate this stuff. So yours gonna be this. I have to probably create a card for this as well. 'Cause this translation is kind of confusing because now I'm not really sure. Like I think it's gonna be 11 times 16, and the other one is gonna be 16 to the power 2. It's gonna be 200 and something, 226 maybe. So it's 48, 60, 108. Anything 60. It's not practical to calculate, I think. 'Cause then you have to, so first you have to calculate in decimal and then divide by 16. Is that correct though? It is still kind of confusing to me, so I'm not really sure if that makes sense. Or do you think hexadecimal is 72? Also, it's saying 16 bytes, so I think that this is probably not correct. I think it's 16 bits. And also, it doesn't make sense to divide the decimals, I think. Or maybe it does. I think if you have the decimal, you should divide by 4 to get the size of the length of the binary. Oh, but that doesn't make sense. It's gonna depend on the number. These kinds of things is very hard for me. It's confusing. Okay, so it's gonna push a relative address from the. I think when it does like this, it's gonna push the actual address from the stack and not the value that is on the address. I think, but I'm not 100% sure. Maybe the one that is highlighting is the one that is pushing. So let's see. This is either gonna be this is gonna be on the RS6. So maybe it was the value. I think you can also uh, select the value here and then click on following the stack, I think. I know you can do it from the register, so maybe I should. So here you can click and put following stack. Maybe it's not. It's only the RSP. Yeah, following stack. So I think it's only the RSP and RBP you can do this. But obviously you can just copy here and go here, I think. and then you can search for expression. Mm. So it was probably a value. Yeah. So it was the value, not the address, I think. Oh, so this is one of the places that I was talking about that there's an XOR between two different registers. So RSP is gonna be the value, the address here, and RCX the value that got from the other one. So it's XORing that. And it's gonna store the result on the left register. So Intel syntax is like that: is you take the right one and you apply that to the left, and AT&T syntax is the other way around. Just pushing RBX to the stack, then subtracting, so it's moving the pointer, and now moving RSX to RBX. So this instruction, I think, is comparing the value here with RCX. Yeah, so it is the other way around, and it looks like it is the same value, C081. So I think probably this place here is the one that is checking to see if the. So I think this place in memory here is the one that holds the value you put there, I think. So I guess this is another question, is how to keep track of the. So because obviously what I want to do is. So I think what is happening, I'm not 100% sure, obviously, but is going to. I think after you put the value there on the command line, it's gonna save that on this address here. So it got the value from this stack, the other one, which is probably a local variable. And now it's comparing the value that is saved on the heap, which is the value that the result's supposed to have, with the value that is on the stack, which is the RCX. I think that's what's gonna. And then it's gonna determine the control flow based on the results. So if it's equal, it's gonna continue with the. It's gonna show the other input, and if it's not equal, it's gonna crash the thing. So, I probably this should be the place where this is happening, I think. So the address in memory is this one. And I think it is the same. Yeah, so this one you can see here is BB. There RCX is BB, and the first one is 0C. So it is the same, I think. C7, 94, 81. Yeah, it's the same value. So I think the comparison is gonna, like the name says, compare and set flags, but I don't remember. So I'm probably gonna ask that. I'm gonna ask ChatGPT what flags. So this is another thing that is very confusing to understand in the beginning, but I guess it just takes time. So I think the way that usually works with comparisons and the tests. The test is at the bitwise end, but I think for like other operations like this, where you're gonna on higher level languages, like where you're gonna have the control flow based on greater than or equal or less than. Usually, how it's gonna happen is that the hardware is gonna subtract one value from the other, because based on the result of the subtraction, it's gonna be able to know if one number is greater than the other or not, and stuff like that. But the issue of this, and the reason why it's kind of confusing, is that you can have negative values as well. So, and I think that the way that So this is going to be based on the instruction set architecture, because different instructions are going to you're going to tell the CPU to take into consideration the sign or not, and that's obviously going to change the result of the subtraction, for example. And the way that the registers are going to work is based on the true sum complement or true complement, which is basically taking the value, then you perform a not operation on the value, and you add 1. And that allows you to have negative values as well. But it is kind of confusing because, like, I think based on this instruction here, is not going to be using the negative or this value, the signed value, signed comparison. The signed comparison is probably going to be another instruction, but not something sure. So it's kind of confusing in the beginning. So if they're equal, it's gonna start. So I guess the other one's gonna no the other a jump if not equal is based on the ZF. So because it's gonna be 0 based on the subtraction, it's gonna be set to 1, which means it's not gonna take the jump. So here I should probably put a label here. I think to put comments you just do the semicolon, but I'm not really sure if it's gonna override. But I guess it doesn't matter because that's okay. So you have to select the instruction base, but I'm not really sure if I trust this response. I think I do because I remember, yeah, I do remember this from other lectures. So usually you're gonna use jump last and jump greater for signed and jump above and below for unsigned. Actually, I don't remember if it's the other way around though. But I know there is this difference. So jump last and jump greater are different than jump below and jump above, and it's mainly because of the sign. I think unsigned. So jump above and below is unsigned. And jump last is signed. Jump above is unsigned. Okay, so did it jump? I should have put the minus. Yeah. Now I'm not really sure if it jumped. So maybe I was wrong. It seems that they are the same value. So this shouldn't jump. I had a hard time also with this Z flag on the other jump instructions because it's kind of confusing. Like because the flag is set if the result is 0, so it is kind of in some situations because of the way that the instruction works there, the jump equal and jump not equal. Like should think about the flag is kind of confusing. But here I'm not really sure because here I thought that it's not supposed to go over. It's not supposed to take this jump. Because they are equal, so that's whatever. I'm just gonna try to go faster. It is kind of weird here as well. So I guess it didn't do. So it did take the jump, which is very weird to me. I guess this is the thing that is kind of weird. No, but it should be sat, I think. If they are the same, the 0 flag should be sat. But maybe it's because of there's something weird going on with the execution. Yeah, I think it's because there's something weird going on with the execution here. So I might have to go over again. Because it seems like it's the same stuff that happened on Godot where whenever you have multiple threads, the debugger, I'm not really sure if that's what's happening here, but I remember on Godot that that's definitely what happens when you're using VS Code to debug C++ and you have a multi-threaded thing and you snap over, then whenever there's a fork between the threads, it's gonna go back and forth between the threads. That's the execution of the threads on the files. And here it seems like it's doing something similar where it's jumping off to other place, but it looks like it didn't go to the jump here. So I'm not really sure what's going on though. I think this, yeah, so rotates bits to the left is like multiplying by power of 2, the number, because obviously each rotation is going to be like one square of the 2 more. So I think it's multiplying by 2 times 10. But this is done for other reasons as well, I think, because it can clean the bits as well because it overflows. So yeah, RSAX is gonna jump or is gonna shift left by 10. So it's kind of weird. Not sure what's going on here. So it's ending CX with this FFF. This is a mask, obviously the FFF, but I don't remember like, why do they do this. I think it's just, obviously, if it's an end, it's gonna zero the places where it's not F. But I'm not really sure what is the purpose behind this. Okay, but this is the final number that it has there. And 0 flag is set, so it's not gonna jump. Or maybe it will. I think it's because it's probably something related to threads here. That is going in 2 different places at the same time. So it didn't jump, it's gonna return. And on this other one, this GS here is a special place that the processes on Windows have. So the memory on processes, which is called process environment block, the name for this stuff on Windows is gonna be the beginning addresses of the process. So like the memory addresses that show here are not the physical memory addresses. They are the virtual addresses from the processes. And then Windows is gonna have on its API the logic for the virtual pages. It's gonna translate these addresses to the physical address, and this is gonna involve the part that I was talking about cache coherence and the other nuances of how the operational system is gonna deal with the different addresses from the processes. So I'm just gonna go fast here. I think I'm probably gonna have to go over again because sometimes it does this and sometimes it doesn't. Sometimes it just follows the execution, but it might be because of the breakpoints that I put there. So now it's splitting the execution for whatever reason. I'm just gonna press F7 a bunch of times. See if I can get you an interesting place. I'm gonna be right back. So I'm probably gonna do this stuff because I think it's very important as well to. I, I'm not. The problem is that I'm not really sure how I'm gonna go about doing this because I guess I can see on the documentation if they have this or somewhere else, which is the stack alignment or stack size. I have to clarify how many bits each row has. Which I think is 16. And then clarify how to do the math there. because like this math is confusing me, so I have to go back because to go from hex to decimal and then translate to the bits there, it's kind of confusing to me because the bits are supposed to represent a decimal value. So if you think about 16 bits, it could be any number. So like, how do you think about the size based on the magnitude? So, and I don't see an easy answer like other than doing the math and then shifting the bits in your head, which is not very practical, I think, or using the calculator, which is kind of slow. So if I can't find a way to, good way to clarify or an algorithm to use in my mind to translate the values, I guess like I can just use heuristics and then like memorize the common patterns, and which I'm probably gonna create Anki. But before I do this, I have to clarify more stuff, so that's why I'm not doing this right now. But I think that this is the main things I'm thinking about. So, like the offsets here, how to make it automatic so I don't have to think about on this stack there. And I think most of the complexity is gonna come, so most complexity, at least for now, comes from the stack relationship with the registers. So it's understanding, so the model that I have right now is that you're gonna have the prologue and epilogue for the, which is basically the stack frame, which is like the standard pattern that people use to move the base pointer and the top of the stack based on function calls. And then you're gonna have the addresses. You're gonna have the difference in function calls, which are gonna be the arguments, whether or not the function has the arguments and the local variables. So the arguments and the local variables are the things that it's kind of confusing, and there is something that I've seen from the OST, which is probably the best courses that I've seen so far, which is, I think on MSVC has Shadow Star, which is a space that they reserve for some stuff. So there is also these nuances as well. So based on the compiler you're using, your stack allocation is going to be different. And also based on the type of the arguments, I think. So I'm more trying to clarify like how to reason about the assembly in the same way that you reason about the higher level languages. It's kind of confusing at first because on assembly you don't have the types. You only have the integer and integer strings, which is ASCII, ASCII, or UTF. I think it's ASCII most of the time. It's just going to be the numbers that represent the characters. And you have the floats, which are the other registers, XMM registers. So basically this channel here, he talks about the Shadow Star. I'm probably going to watch the course again here. From my opinion, based on what I've seen, these two are the best courses on this channel. So this two and the vulnerabilities on C family is also very good. And so I'm probably gonna watch this again after I watch all this other stuff. So I'm just gonna, I think I'm gonna start again because it's kind of weird. So I want to see if it is gonna do the same thing if I go over again. Which is like, it seems that it's executing in two different places at the same time. It's making me confused. I'm not really sure, like I said, if I'm going to try to solve the challenge. I think even if I try, it's gonna be hard. I expect it to be hard because this is supposed to be, I think, one of the easiest ones, and it gets harder on the other ones. And even this one is kind of hard. But I think that if I mainly try to solve, what I probably would do is go from IDA. I think it's a lot easier to go from this place here. So you just go from this place and then you check to see the conditions on the jumps, and you try to figure out what's the state of the registers have to be in order for the jump to be taken, so that the control flow leads to this path that is going to have this thing here, which is probably going to be some code that creates a file with the flag. And this is another thing that I was thinking about, is that probably the flag, uh, uh, it can't be something that is written, so it can't be static on the program, otherwise it would be too easy to figure out because you just search for the pattern on the code. So I think most challenges is probably going to be on runtime. So the control flow of the program is going to determine, it's going to create the flag on runtime, and it's going to be based on the inputs. So I think that's all that matters. So the question and the complexity is going to be on how to clarify the change of the registers based on the memory and the control flow relative to the inputs that the program has. I think one interesting thing to do before I run this again is to look into this address here. So I should take I wonder if there is a way to copy this. It's basically this value here. I copies the whole thing. It's a different address. It's Control G to search for the address. And so now it probably changed already, so I should have. But maybe I think the numbers are on the first line here are still the same. It's basically gonna be these values here, I think, up until the B. Obviously, I can do the math to translate, but kind of this is something that I have to clarify as well. Just I think from what I've seen, the easiest way people recommend to the easiest way I found to me to think about the hex numbers and translate them into decimals is to first translate into binaries, because each hexadecimal value you see is going to be 4 bits. So first you translate into bits in your mind, and then you translate into decimals. But it's still very confusing. So I guess, and you have to probably the base you multiply by the number. So each time the base is gonna be, but that doesn't make sense. Maybe it does actually. So what I'm thinking about, like, obviously the first B is gonna be 11. So in binary is gonna be this value. 10 is this, and B is this, and this is 11 in decimal. But this is kind of weird. I guess we multiply by 2. So because you're converting to binary, it's going to be by the power of 2. So the 11 on the other is going to be 2, but now, so it's going to be 32. So each letter we move to the left to multiply by 32, I think. Yeah. Because you're shifting by 4, so it's 2 to the power 4, which is 32. No, it's 16, yeah. 2 to the power 4 is 16, so each letter you go to the left, you multiply by 16. So the first B would be 11, the other one would be 11 by multiplied by 16. And then I think you sum all the numbers. Obviously, it's going to be very hard to, probably like impossible. Not impossible, but not practical to do everything in your mind. And yeah, so it probably means that the number is not, it might be actually. I think it's probably a larger number than the one that I got on the result there. I'm gonna press F9. Oh, so this is another weird thing. Yeah, I got this a couple of times as well. So I got, yeah, it hits an exception. Maybe the math was wrong, but this happens sometimes as well before you even do the math. I think if you wait for a long time, it hits an exception. It might be because of the database, since it's saying the lock here. Which is very interesting. Well, the math is correct, so it should be just because of the it hits an exception there. So if press F11 or F9 is gonna rush. Yeah. So this is the last part, I think. I wonder if I press F7 it doesn't do anything. I think you can snap into the syscall. I wonder why it's not showing anything here though. Let's see something. I guess I can put on the calculator there. So I can see if the value that they put here is the one that they're gonna ask there. That's probably what I'm gonna do, but stopped for some reason here. It might be because of the breakpoints. But I'm pressing F8, F7, F9. It's not doing anything. Also now, so maybe it was just had to wait there. Let's see. Hmm. This is interesting. So there's something happening because of the breakpoints, I think. I don't understand very well how the breakpoint works, but I think like I just superficially seeing think it's based on a trap, I think. Trapped instruction. I don't remember really well. I think that the from a video that I've watched from the creator of the x86 DBG, the way that it works is based on events. So the debugger listens for events, and then depending on what kind of events you have, it's gonna set an instruction there, I think, which is an interrupt. And that's basically what the breakpoint does. And you have in 4 registers to interrupt on the hardware itself. And I think that's you. I'm not 100% sure about the other kinds of interrupts. But I think it's because I have the breakpoint there, it's not showing the input now or the out. Yeah, the it's not asking for the thing here or something like this. I don't know. So I'm gonna remove the breakpoint from here and see if it's gonna work. I mainly want to see now if the value on the address here is gonna be the one that they asked for, the sum. It's gonna be the result of the sum. ChatGPT. So on the jump here, I think that you control whether or not it's gonna be signed based on the way that you put the numbers on the registers. But I'm not really sure about this though. I'm just pressing F9 a bunch of times. It's still nothing. That's weird. It's probably because I didn't have a bunch of breakpoints before, so it went faster. Either that or there's something else going on. I'll wait for a multiply. So it should be like it should show the sum here. Mm. So one thing that I can try to do is put the value on the. Let's see what's value. The problem is I think it has to be the other way around. So it's gonna be it should be. It's gonna be should be 78, 93, 63. Maybe I'm wrong, but the thing is I'm not really sure if that's what's supposed to do as well. It's too high of a value should be the result. And if I change the order, it's probably going to be the same thing. So it's probably something else. But I definitely do think there's something to do with this address there, because obviously it's using that to compare with the one on the register. So I do think that there's something to do with this. The way that they do the comparison, or the way that they handle the values of the inputs. And this is interesting as well. You can just look into, you can put a breakpoint before the syscalls, then write down the values on the registers and see how they change later. As obviously it's gonna have to, and just based on what I've been experiencing, just stepping into, that's basically all that is gonna be happening when you program. You're just gonna have a flow of memory based on the decisions on a line. So you walk the line of the instructions, and each instruction is just a decision. And then you have the flow from the registers to memory and from memory to registers. It's basically everything that's is gonna be happening. And the main difference between the stack and the loop is just gonna be the stack frame, which is just an abstraction. And the difference between the loop and the if-else statements is just the address, the relationship between the address that the jump is gonna happen with the previous ones. So I think on the control flow on the compiler, they call that a backedge. So control flow graph is the graph of the, like the name says, of the control flow of a program, and is one of the steps on the compilation process that happens. So, and the reason why they do this is because you can do a bunch of optimizations based on the control flow path. So it's basically going to be a graph, direct is acyclic, actually it's not acyclic, but direct graph. And on this control flow graph, the loops are determined by the back edges, which is just basically this difference between the jumps. So if else is a loop that goes forward. Just everything is going to be simplifying to a sequence of instructions where you take decisions, which is basically the bits. So like space-time itself is the range of infinite potential over 0 and 1. And the way that you encapsulate the geometry of space-time is just going to be directly equivalent to the symbols you use on the range of infinity, because the fluctuation of the gradient is going to be like the geometric structure of space-time. And that's basically all that is happening. I'm gonna try to remove some of the breakpoints, because obviously it's stopping. So maybe like all these breakpoints here are part of the loop that I suppose, but it's weird because you should have written already the thing that asks for the sum. Not sure why it's taking so long to get to the points. I was gonna write this stuff here. Like symbols and mathematics is just the same as binary. It's just a higher abstract level of the same thing. Like the symbolic representation of mathematics is built on top of the binaries. It's just different levels of resolution of the same thing. This is all about perspective because everything is going to be relative. And I used to think that mathematics is like programming is a computer science is a subset of mathematics. But now I'm thinking more is the like the two sides of the same coin. It's just different ways to observe the same thing. And the observation is more a reflection of the synchronicity of the network of experience that creates the projection of the symbols. Because that's what geometry is. It's just different levels of observation of the same thing. And the process of computation is the frequency of the of space-time. It's the frequency of the density of the symbols because it is essentially the same thing. Like the density, which is the frequency of the observations, creates the symbols, which is geometry. Because geometry is basically computation over a reference frame, and that's what computing is. So I'm gonna remove all these breakpoints here because it seems I'm gonna remove and then see what happens if it keeps stopping or not. And if it doesn't work, if it doesn't show anything there, then I'm just gonna try to start the thing again. But like the more experience I have as well with this, I think it's probably not gonna be enough. I think it's probably Ada or Ida, however you say this, is more my style of thinking. The problem actually is like they are complements to each other. So yeah, so like x64 DBG is more for runtime, and the IDA is for static analysis, and they complement each other. But the reason why I like IDA more so far is because it allows you to have a bird's eye view, and this is kind of hard to like keep track of the unless you put labels on everything. But even if you put labels, it's kind of annoying to because you only have one line of execution. So, but it might be because I don't have experience, so there might be a way to do this here. Like it would be better if you had files, for example, where I can look into the different parts of the thing on different files. I'm gonna actually put one here because I think that this is the function that is going to this is the function that creates the that waits for the input, creates the sum. Maybe the sum is created before because the sum is gonna be ASCII characters, I think. So you put the values on ASCII characters to put on show on the input there, but then you receive an integer. I guess like this is another thing that would be interesting to test maybe just like put different patterns there just but I guess like this is the whole part. This is the whole thing. Like instead of making just wild guesses on different inputs you can put, it makes more sense to look into the control flow and then based on the control flow you see what kind of inputs would be interesting to test. This one I put, so I'm gonna leave this one here if it goes there. Because it looks like he's going to call memcopy, so I was interested in seeing like how does it work? How does it copy the bytes? Like you can think about the memory of the computer as a relative reference frame of an observer. That's why it's interesting with the things with the threads. Like threads are attention. So like space-time is gonna be the synchronicity of the reference frames, both on because it's a fractal pattern. So it's gonna be both on the computer and outside because it's a network. So it's like self-similar. So the synchronicity of the different parts of the like different times is what space is, and that creates the symbolic representation, which is computation. So like computation, this is like this I thought about a long time ago. That's like when I hear people saying that computers think in binary, like the computers don't think in binary, they use binary to think. So it's like achieving a higher, achieving the, achieving symbolic representation through a higher frequency of computation because you're using the bits to represent the information. But essentially it's the same thing because you are just approaching the gradient of infinity. And I think that's basically what mathematics is as well. Like it's two sides of the same coin because the symbols are the projection of the symbolic representation of human beings. So it's like a reflection of your network. So I'm not really sure what happened here. So I guess I'm just gonna press enter. Also, it looks, for some reason it didn't put, I think it was because I had the breakpoints. It didn't put the result there. So when I press enter, but now it's probably gonna go into the path that creates the exception. I stopped here in the same place. So I guess I can check this again. I can go here. So is it the same address? It looks like, yeah, obviously it's going to be the same because it's hard coded. And I think this address is just relative to the process. So like they can be, I think, I'm pretty sure that they are different depending on which program, and you can use a plugin on x64 DBG to use the same address so that either uses the same address as the x64 DBG uses. So oh, it's because it's cutting here. Okay. So it looks like it is this address. Maybe whatever. It looks like it is the same though. So it looks like they are the same value. So it's not gonna jump there. So I think that it maybe it's interesting that there is a string here. Go debug. Interesting. So it looks like they are the same value again. So and I just press enter there. So maybe that it's probably not the. I think it's definitely related, but it's not going to be the same thing. Like the value on the RCX register is not the one that is receives the inputs. RC right RC stands for counter as well, register counter. So I think usually this is the register that is used to count stuff. So on loops, for example, I think that's probably most of the time the RCX is used to count the iterations of the loop. I think it's not gonna jump. And now it's not going over the other thread there. So Max masks the thing again. And it's still kind of weird here. So returns. I think there's something weird going on with the RIP pointer. It might be because of the multiple threads thing. Yeah, so it's kind of hard to see. Yeah, I have no idea why he's doing this. Like he's going over one place and the other. The thing is, it's like it's hard to know what is the if it is on the if it is going to the correct line after. So the other thing, like so there's probably a place where they cache the breakpoints and the information for the executable you open there. So I'm thinking I should probably either figure out how to delete so I can start like from the beginning on this because also the prefaces, the options here. So I make sure that I start from the beginning of the executable. Because I'm thinking I should start from without any breakpoints and making sure that I'm starting the execution at the beginning of the main function from the executable. Then the main thing to figure out, to try to understand is after the input, what register is going to have the value from the input. And then from that point, understand how the control flows are going to change based on that register. And it's just very weird. It's like I feel that it's not going over. There's something weird going on with the pointer there, the RIP. It might be confusing because of the stack though. Because like it's back tracing from the points. So maybe, yeah, but I think it's something else going on. It shouldn't be going over call normal instructions. So check and just see if flag is set to 0 on this address here. So it's 1. So it's not gonna be 0, I think. Yeah, so it doesn't jump. I'm curious now because I didn't put anything there. Just remember that I just pressed enter and then put the result. So let's see if it's gonna crash. I'm gonna write down. I'm probably gonna put this on. I think maybe on the list there, so like I don't have a bunch of stuff. Maybe here on this spreadsheet here, because I have to. So I think it's probably gonna be worth it to train this more. Because the problem is that with the Anki cards that I have there, like it's good to translate one hexadecimal to binary, but I wanna see if I can create a system to like make it easier to translate the addresses on my mind. On like the thing is, it doesn't have to be the exact number, but like because right now when you and I assume that for a lot of people it's probably like this, unless you have experience. Maybe maybe I'm not really sure though if like this is something that people that have experience also do. That uh, like a way to look into the number and immediately tell if it's greater or lower than other numbers. I think that's what I want to see if like if there is a way to do this, because that way it's gonna be a lot easier to keep track of the things there. So probably I'm gonna write this down here, I think, and then I'll think about where to put this later. But I'm probably gonna create Anki cards. I want to see how the Anki cards on the other one are done. Maybe I'll do this on stream as well. I think I'm probably gonna do this on stream. So see how the other Anki cards are done, then create an Anki card that puts the number and then um, either the decimal. Thing is that like it's not very clear to me, so because another point of confusion is on the translation of these different formats, and how to make sense of them on an intuitive way. I guess the inputs and outputs are decimals. Like they don't have to be, but usually that's how it's gonna be, I think. Well, ASCII characters are gonna be hexadecimal. I think whenever I have numbers, inputs and outputs are gonna be decimals. And then if I have characters, it's gonna be ASCII, both on the input and output as well. So I think it's more. So input have decimal, so from decimal to hex decimal. The problem is you have the binaries on this stack. So it's probably gonna be hex binary, which makes sense. Yeah, because the registers are on bits. So I guess yeah, but the numbers there on the register are also on hex. That's why it's confusing. Yeah, so I think this is one of the points of confusion. So if you have a 16-bit or if you have a 64-bit register, but the number inside of the 64 bits is gonna be on hex, like how does that make sense? Because like the representation here is gonna be different than the size, I think. Yeah, so I think that the representation is on hex. Yeah, but it's still kind of confusing. I guess this is the point of confusion. One of the points. because like the thing that I'm doing in my mind is to translate the one hex letter, for example, or even hex number into 4 bits. So like if the number here is hex, then it should be multiplied by 4 the size on bits. But I guess that would make sense. Yeah, that makes sense because the amount of here is gonna be 64 divided by 4. So basically this conversion here. So I have to create Anki cards some way that's are gonna allow me to. So in order to do this, I have to clarify the standard of addresses before, because I think that like the process space, the relative addresses on the process space are always going to be consistent because otherwise you wouldn't have this standard. But the absolute numbers are going to vary based on application. So like the range of addresses is going to be consistent, but so the relationship between the addresses within themselves on the process is going to be consistent. But the actual absolute value of the process is not because it depends on application. So which means that so the question is whether or not it matters to like take the absolutes into consideration. Because obviously if I'm gonna train this, it's probably better to use addresses that I'm gonna see all the time. So obviously the first thing that I'm thinking about is just doing based off these addresses here. So obviously I don't expect to be able to do this on my hand, the translation, but I just want to get better of like seeing a hex number and then immediately putting that into a range of decimal in my mind. It doesn't need to be perfect, but like to have a more intuitive conversion between the differences on the addresses. And if I'm gonna train that anyway, then it's probably better to just use addresses that I'm gonna see all the time, obviously. Well, press F9 here. I'm gonna stop streaming. So it did crash here. This is also interesting. It's outputting values on the registers, but I think it crashed because of the wrong results. So never put the wrong results. Raise an exception. Let's call up to trans. And I think that there is a problem with the trans. Not a problem. It's probably a design like this, but when you put the wrong results, it raises an exception on one of the threads. And then the program crashes because of that. Well, JS, no, JS is going to be this segment. Yeah, so it stopped executing. So I'm going to stop streaming here. So I'm going to watch a bunch of videos and study. I think probably next time that I stream, I'm going to Thing is, I have to clarify this stuff first about the relative addresses. I'm not sure how long it's gonna take. But I do think that I'm going to. I'm not 100% sure, but I have in my mind right now as an option to create this Anki cards in order to like have make it more intuitive, this translation between the hex and the decimals in my mind. So like when I look into the address here, I don't have to. It's easy. It's gonna be easier to. I have to figure out a way to make it easier to see, like if a number, if a hex number is smaller or greater than the current instruction pointer, for example. Yeah, so I'm gonna stop streaming here probably next time. I'm just gonna continue to do this thing, or I'm gonna go back to the stuff that I'm doing. Which probably I will go back anyway at some point. On the yeah, I'm definitely gonna go back to uh, studying how VS Codes translate the VS Code gets the paths of the folder. How VS Code creates. That's the next thing that I have to do there on the other project. So get the folders, show the files and subfolders from a folder. So see how VS Code does that, and then do that on the file system on Godot. That's what I'm trying to do there now. So I'm probably gonna do these two things at the same time. So this stuff here, so I'm probably gonna go back and forth between them. So see you next time.